evaluation metrics, precision and recall. By the end of this video, you will be able to form a precision matrix to explain the results of a classification model and form a recall matrix to explain the results of a classification model. Now, whenever we encounter the problem of an imbalanced dataset, we often take the help of the precision and recall. This duo handles the imbalanced dataset like a breeze, depending on our requirement. Now let's look at the formula of the precision first, and we will understand it in a moment. Precision is defined as the ratio of number of positive predictions that are actually positive and the total number of positive predictions. Now using the confusion matrix, we can easily write the formula of precision. Okay, we have a formula in our list now, but how is this going to help us? Let's understand how the precision works with an example. In this example, consider that you are a detective tasked with catching a group of criminals. And you know that those criminals are attending a party full of important people. As you can imagine, wrongly declaring any of these important people as criminals can have dire consequences for your agency. So as a detective, you can only arrest the criminals. To be perfectly clear, avoiding the wrongful arrest of these VIPs takes precedence over catching the criminals. In order to do that, we must avoid arresting VIP as criminals, right? Take a moment to ponder this. Avoiding arresting a VIP as a criminal is analogous to minimizing the false positive. But in order to minimize this false positive, it is essential to understand that there is a very high chance of a real criminal escaping and not being caught. This means an increased false negative. In a nutshell, precision is used when we cannot afford to have false positives, or avoiding false positives is more essential than encountering false negatives. I hope you are catching up with me so far. Now let's recall the same predictive model that we made for the cancer example we had used earlier in this topic. And let's calculate the precision for that using its confusion matrix. Here we get 33%. The predictive model, which had 98% accuracy, does not look so precise now, does it? Now let's shift our focus to another evaluation metric which we'll learn in this video, that is recall. This metric is also commonly used in the industry. Recall can be defined as the ratio of number of positive predictions that are actually positive and the total number of actual positive values. Looking at the confusion matrix, this can be defined as TP over TP plus Fn. Again, we'll take up an example to explore how recall works. We will evaluate the cancer detection model again, this time with the recall metric in mind. Let's put input values from the confusion matrix into the recall metric formula. It turns out to be 66%, which means only 66% of actual positive values were predicted as positive. Again, the accuracy metric turns out to be misleading. Let's take an example to understand recall better. Consider that you are at the airport and passing through the metal detector. The aim of the security at the airport is to catch all the people who are carrying weapons. In order to catch every person who is carrying a weapon, the security guard will check any person for whom the metal detector beeps, irrespective of whether the person is innocent or not. In other words, it is more important to catch the weapon carrier as compared to avoiding an innocent person being checked. If we look at the definition of recall, trying to catch every weapon carrier is analogous to minimizing the value of false negative, that is, no weapon carrier should slip through. The idea of trying to catch the people having weapons leads to all the innocent people being checked by security, which is analogous to the high false positive rate. So in a nutshell, recall is used when we cannot afford to have false negatives, or avoiding false negatives is prioritized over encountering false positives. Now there happens to be a relation between precision and recall. If we focus on increasing the precision metric of any model, there is a drop observed in the recall. On the other hand, when we try to maximize the recall, the precision tends to drop. But this is generally a weak relation between the precision and recall. If we are not sure which metric to use among these, there is another metric called F1 score, which is nothing but the harmonic mean of the precision and recall. And the F1 score is always maximum when the value of precision and recall is equal to each other. But there are some cases where we cannot differentiate between the different two models using precision, recall or F1 score, as these values may be exactly the same for the two models. Now, your question will be, if all the classification evaluation metrics we discussed so far yield the same result, then how do we distinguish which one is better? For this, we will be looking at the log loss. Sounds familiar, right? It is the cost function of the logistic regression which we have already discussed in the training. If you do not remember the log loss, I would advise you to go through the respective topic and revise it. In the next video, we will discuss how the log loss model helps in distinguishing between two identical models. See you then.